morning, this is Ms. Billerbeck, and we're going to talk about 12.1 pyramids. So pyramids are classified by their bases. So this one's a triangular base, so it's a triangular pyramid. A square base, so a square pyramid. A rectangular base, a rectangular pyramid. And a hexagonal base, so a hexagonal pyramid. Now, there's a lot of different types of pyramids, so there's a lot of different pyramid names, and they all depend upon the base. And we have other vocabulary for pyramids as well. So pyramids, unlike prisms, only have one base. So prisms have two bases that are parallel, but a pyramid has one base and it ends in an apex, and you're familiar with the pyramids of Egypt. So that's where we most likely, that's what we most likely think of when we think of pyramids, is the Egyptian pyramids. Okay, so the top of the pyramid is called the apex. The side of the pyramid is the lateral face. And the edge of the lateral face is called the slant edge. And the height on that lateral face, where it ends in a right angle with the base, is called the slant height. And that's what we need to find when we want to calculate the lateral surface area. So we need to find the slant height for each face, if the faces are different. Okay, the height of a pyramid extends from the flat base to the apex of the pyramid. And then the height is drawn from the apex at a right angle to the base. Now, the height of a right pyramid meets at the center of the base. This isn't quite the center of the base, so I don't have a right pyramid drawn, but I will show you one. So a regular pyramid has a regular polygonal base. So what makes a regular polygon? If all the sides are the same on the polygon, then it's a regular polygon. So all angles and all sides are the same. So a regular rectangle is a square. That's what you're familiar with, okay? So that would be an idea of a regular polygon, is a square. Okay, but you could have many sides. And that's why we say poly, which means many, and gon means angle, so many angles. Okay, so to find the total surface area, we add the base area plus each one of the lateral surface areas. So the lateral area is the sum of all the lateral faces, the areas of the lateral faces. Okay, let's take a look at some online representations to help you understand more about pyramids. All right, so here is a right pyramid. So let's look at this. So we have a lateral face here that's shaded in, and the lateral height is shown, and it is also going to the midpoint. So that makes me understand that this is a right pyramid as well. Or one of the aspects of a right pyramid would be that I would have isosceles triangles, and the height would extend to the midpoint. So let's look inside now. So we have the center of the base, and the height is extending to the center, which is exactly the definition of a right pyramid. And this is called the true height, as opposed to the lateral height, which is right here of the pyramid. Okay, so that's an excellent visual on the difference between the slant height or the lateral height of the pyramid and the true height of the pyramid. Now, if we look at a pyramid like this, there's ways to represent the areas of the surfaces when we're actually considering surface area. So we can open up the pyramid and just look at each face as a flat surface. So we find the area of this triangle, this triangle, this triangle, and this triangle. And we add them up to get the total surface area. Now we don't have to just open the net from the base. We can also open nets like this. And then this would be the exact same surface area. It's just a different way to open up the net. But that's what a net is. All right, let's do an example of surface area here. Okay, so we're given a right square pyramid. That tells us a lot of information. It means that we have a square base, and we can represent a square base like this. And we know that when we do the sides here, that the height's going to come right down to the center of this pyramid. Okay, we also know that the sides A, B, C, D are 10. So we have 10 centimeters because it's a square, and the slant edge is 13. We're dealing with meters, not centimeters, so let's do that. So 10 meters, 10 meters. Okay. All right, so finding the area of ABC is pretty simple. So ABC, D, is just 10 times 10 meters times 10 meters, which is 100 meters squared. Okay, so that one's easy, but now we have to find, this is A, B, C, D, and then V, the vertex or the apex is up there. Okay, so now we need to find the lateral area, the surface area of the side triangles. Now there's 4 of them. So if we find one, we can find the other 4. So let's go take this apart then. So if I have the triangle that looks like this, and it's 13 here, 13 here, and 10 here, we know that it's an isosceles triangle, so the height hits right in the middle. So now we know that we have the base here is 5 meters. Okay, so what I've done is I've taken this height down here, and I know that this is 5 meters right here. Okay, so I can find that height. I need to find this height right here in order to find that surface area. And then once I find this lateral area, I can multiply it by 4 and find the others. So I can use the Pythagorean theorem to do so. So I see the Pythagorean theorem is a squared plus b squared equals c squared. Okay, so let's look at what I've got. So if I call this, whoops, I'm going to call 5 meters A. Okay, and I'm going to call the 13 meters C, and height is going to be B. Okay, so here's my C, my hypotenuse, my A, and the height's going to be B. All right, so I'm going to rearrange this and move the A to the other side by subtracting A squared. So I have B squared equals the square root, I'm going to square root that to get B, is C squared minus A squared. Okay, C squared is 13 squared minus 5 squared. So then I have B equals square root of 169 minus 25, which gives me the square root of 144, and that's 12. So now I have my height. Okay, so finding the area then is not going to be very hard now. So I have the height for the triangle and the base is 10. So the area of one triangle is going to be 1/2 base, which is 10 meters, times the height, which is 12 meters. So I'm going to choose to take half of 12, which is 6, and 6 times 10 is 60 meters squared. So that's only one of the triangles, and there's 4. Okay, so now let's go back up here. I'm going to make some room and erase the Pythagorean theorem here. So my total surface area is this then going to be 100 meters squared for the base plus 4 times 60 meters squared. Well, 4 times 60 is 240 plus 100 is 340 meters squared. So that's my total surface area. All right, let's look at another one here. Right, so if I'm given VABC here, I want to find the lateral and total surface areas. Okay, so here I see I have a right angle here on this triangle here and a right angle here. So I have a few triangles to find some areas, okay? But the right angle gives me the height and the base. So if I have one triangle, or actually I have two triangles that look like this, if I draw them separately, 3 and 4, so that area then is 1/2 base, which is 3 times 4. So that becomes an area. If the 2's cancel here, it becomes 6 units squared. So I have 2 of those, 1 and 2 right here. This one here, we'll call this area 3 right here, down here. So area 3 then looks like this, where we have 3 and 3, and it's at a right angle. So that one is area equals 1/2, and that's going to be 3 times 3 squared. Okay, so that ends up 9/2 units squared. Okay, so the troublesome one is going to be, well, what is this one here? So we have to figure out what that big triangle is, and that's what's going to take a little math. Okay, so first of all, we have to do the Pythagorean theorem to find our missing side here, which is opposite the right angle. So the missing side is C. So we need to find that side. And we also need to find, that's going to be C1, and we also need to find C2, because this is C2 and this is C1. Okay, so once we find those, we'll be able to do a little something with this. Actually, when we want to find the area, we don't even need C1. We just need C2. Well, let's think about that. No, we do need C1 because we are going to, so what we're going to look at here is if we have C1, C1, C2, and we come down here and we break C2 in half, because it's an isosceles triangle, we're going to need to know this to find this height here, okay? So that's why we do need to find C1, which is not going to be very hard. So if we have, again, use the Pythagorean theorem, a squared plus b squared equals c squared. Okay, we have 3 squared plus 4 squared equals c squared. Okay, so if we take the square root of everything, we will find C. And that's what we want to find. So now let's move this around. C is then going to be the square root of 9 plus 16, which is the square root of 25, which is just 5. And again, that's a Pythagorean triple, a 3, 4, 5 triangle. So there's a lot of use of 3, 4, 5 triangles. So if we see that or multiples of that, we shouldn't have to do this. Okay? We should know a 3, 4, 5 triangle. There's also 5, 12, 13s and many other Pythagorean triples. So we should know our Pythagorean triples to save our time. Okay, so with that in mind, now we know that this equals 5. So now we had to find out, well, what is C2? So this is C1. Okay, so C2 then is going to equal, and we do not know that that's we know that this is going to hit halfway. So let's think about this. So we have half of C2 is going to be this base right here. So half. Let me use the black pen. So we need half C2 here. So that's why we have to find that. And we can find C2 from this base here. So C2, we see we have one side's 3, the other side's 3. So the square root of 3 squared plus 3 squared equals square root of 9 plus 9 is the square root of 18, otherwise known as 3 square root 2. Okay, so that's not easy, but that's C2. We could have found that with special triangles too, the 45, 45, 90 triangle. One day you'll learn about that. Okay, so now we have C2, so half C2 then is going to be 3 halves radical 2. All right, so we need to find H now. So H is then going to be the square root, and we know C1 is 5 squared minus, and we're going to take this 3 radical 2 over 2 squared. Oh, this is going to be so pleasant, won't it? Okay, so then we get 25 minus, and 3 squared is 9, times the 2 is 18, divided by 2 is 9. And that equals the square root of 16. Can you even believe that? So the height is just 4. All that work, and the height was 4. Can you believe that? All right, so now we know the area of that one. So that's 4. And we had C2 was 3 square root 2. Okay, so let's put this all together. Let's get these areas together. So another board so we're organized here. Whoops, sorry about that. Okay, so let's get some space here with this board. Okay, so we have the 2 triangles that we've already looked at, A1, and this is A1 here, which is the same thing as A1 there. Then we have let's call that, instead of A3, let's call that one A2. Then we have area 2 is right here at this base. And then the final one we're going to call A3 right here. So A3 is this one. Okay, so we're going to add it up. So the lateral area, sometimes abbreviated LA, is going to be all the sides. So the lateral area is A1 plus A1 plus this big face, which was A3. Okay, so A1 ended up being, we had 6 units squared plus 6 units squared. And then A3, the area for that one, we need to figure that one out. So A3 is 1/2. The base is 3 square root 2 times 4. Okay, so half we have, there we go. So area 3 then equals 6 square root 2 units squared. Okay, so our base was 3/2, the height was 4, so that's 12 square root 2, and then half of that is 6 square root 2. So plus 6 square root 2 units squared. Okay, so then our lateral area is 12 plus 6 square root 2 units squared. The total surface area, abbreviated as SA, is now going to be A1 plus A2. We're going to do 2 A1s plus A2 plus A3. Okay, so all we're going to do is take the lateral area and we're going to add A2 to it, basically. All right, so surface area then equals, so we had 12 plus 6 square root 2, and then we find what was A2, which is 9/2 plus 9/2 units squared. And we can combine this one and this one. So that's 24. If we multiply this by 2 over 2 to get a common denominator, we have 24 plus 9 is 33 over 2 plus 6 square root of 2 units squared. So that's basically going to be, when we reduce that, so 12 plus, and then that's 4, so that should be 16.5 plus 6 square root 2 units squared. So that's the surface area of that lovely shape right here. The surface area of this shape. Okay, so surface area is not that easy. I prefer to find volume. So let's find the volume now. Okay, so the volume of a pyramid is 1/3 base area times height. Now, don't get this confused with little b. So a area of a triangle is 1/2 little b times height. When we're talking volume, it's big B times height. So base area times height. Okay, so that's an area for when it's a capital B versus a little b is just a base, a linear unit, versus that's an area, the capital B. So let's not get that confused, okay? All right, so let's take a look at a net really quickly so we can see what we're talking about. Okay, so this is a prism right now. So it's a triangular prism, and I'm going to make it into a pyramid by moving a few of these apart. So the volume of a pyramid is 1/3 the base area times height, whereas a prism volume is base area times height. But a pyramid is 1/3 base times height. So let's take a look at what that means. So if I slide that away, and I slide this away, and then I rotate it, look at that. They're all the same. Okay? So basically, we're just taking, when we make a pyramid, It's basically 1/3 of a rectangular or a prism based on whatever base it has. This one happens to be, well, this looks like, let's see, no, it's a triangular prism right there because the bases of it are triangles and we have the heights of this prism right here. Okay, so that's where this formula comes from. 1/3 base area times height for pyramids. Because for prisms, it's just volume equals base area times height. But when we talk about a pyramid, we have 1/3 base area times height. Okay, so this is for prisms, volume of a prism versus volume of a pyramid. Okay. All right, so if I have a hexagonal pyramid, and it has a base area of 42 centimeters. So base, the big B is 42 centimeters squared. And its height is 9 centimeters. So they gave us everything we needed. The volume of a pyramid is 1/3 base area times height. They gave it to us, so 1/3, 42 centimeters squared times 9 centimeters. So 1/3 of 42 is 14. All right, and so we have 14 times 9, so volume equals 9 times 4 is 36, carry 3, 9 times 1 is 9, plus 3 is 12, so centimeters cubed. Volume is always centimeters cubed. Area is always square units. Okay, so volume is always cube units, area is always square units. All right, let's look at another one. Okay, so a rhomboid pyramid has a base has diagonals of 7 inches and 12 inches. So we have a rhomboid pyramid. Oops, let's make that like that. Okay, and then, okay, so it has 2 diagonals. So if we take this rhomboid, a rhombus, and we look at its diagonals. Okay, so we have one diagonal like this, one diagonal like that. Rhomboid diagonals are always at right angles. So one is 7 inches and one is 12 inches. So the area of rhomboid, a rhombus, is 1/2 diagonal 1 times diagonal 2. Okay, so we have 1/2 times 7 inches times 12 inches. And that equals, if I take this and make that a 6, that's 42 inches squared. Okay. All right, so now we have that, so we need the height. The height is then 10 inches. So the volume is 1/3 the base area, which this is the same thing as a big B. So 42 inches cubed or squared, because this is just area, and then times 10 inches for the height. So 1/3 of 42 again is 14. So our volume then is 14 inches squared times 10 inches. So the total volume for this figure would be 140 inches cubed. Okay, so we just have to find that base area, find the height, and we're set when we find volume. Isn't that much easier than surface area? All right, so this last example is going to be a little troubling, but we will get through it. Okay. All right, so first we're going to find the volume, and we know that's a piece of cake. Okay, so finding the volume and of this figure. So first we can find the volume of this prism. So the volume of the prism is length times width times height. So if ABCD is a square, that means that this is also 8 right here. So we have 8 here, 8 here. So it's easy enough to find that. And then we have the height here of 12. So this is just 8 times 8 times 12. Okay, so 8 times 8 times 12 ends up being 128. And then we have units cubed. Okay, so 64 and 64 times 12 is 64 times 12 is, oh, sorry, that's not right. I was reading something wrong. I had pre-calculated this. It's 768. There you go. Units cubed. That's a big error. Okay. So anyway, I did that I'll do that quickly for you. So 8 times 8 is 64 times 12. And then we have 128, and then we multiply by the 10, so we have 64 here, so that's just 768. So that's how I got that number, okay? All right, so now we find this. Now, this one's an unusual little prism because it's not a right prism, but see how this line here goes all the way here and it's at a right angle? So that tells us that this is the height of that prism, and not the prism, the pyramid. So the pyramid height, so height of the pyramid is 6 units. Okay, so we know the base is 8 times 8 because it's a square. So the volume of the pyramid then is 1/3 the base area, which is 8 times 8 times the height, which is 6. Okay, and 1/3 of 6 is 2, so 64 times 2 then is 128 units cubed. So the total volume then is 768 plus 128. Now sometimes it's just easier to add like this, so you have 16, 9, and 8. Okay, so we end up with 896 units cubed. Okay, so that's our total volume. Now for the surface area. Okay, so this is where it gets a little rough. So let's get a whole new sheet here and try to do this right. Okay, so I'm ready for lots of work. All right, so surface area. Again, we want to keep our Pythagorean triples handy. Okay, so if I have 6 here and 8 here, this is a multiple of a 3, 4, 5. 2 times 3, 2 times 4, 2 times 5, 10. And the same thing here. If this is 8 right here, this is 10 here. Okay. So the other thing we know is that if this is on a wall, say, this is also a right angle here and a right angle here. So now we have the height, the base and the height of this triangle and this triangle. We have the base here, 8, of this triangle and this triangle and this triangle and this triangle. So now we can figure out all the areas of the pyramid. We don't count this base because it is not on the outside. Okay, so we don't count the inner base, but we are going to count this base because it's on the outside. And then we have 4 of these areas, which are all the same. So let's label the ones that are the same. Okay, so this area and this area are the same. This area and this area are the same. And then these side areas, I'm going to call them A3. There's 4 of them. A3, A3, that's also A3. Okay, A3 is back here. And then A4. Okay, and we have another A3 right here as well. So this front surface here is A3 as well. So there's 4 A3s. So let's look at how we can do this. So our total surface area is going to be, we have 2 A1s, we have plus 2 of the A2s. Okay, so that makes the top part of that pyramid. Then we have 4 A3s, 1, 2, 3, 4, and then 1 A4 at the bottom. And that's going to give us our total surface area. Okay, so let's calculate all those areas. All right, so A1, I'll draw it out. So A1 is, we have a right angle here, and this is 8 and 6. And there's, so A1 equals 1/2 6 times 8. Okay, so that's just 3, so we have 24 units squared. Okay, A2. Okay, we have our right angle here. This is 10 and this is 8. So we have A2 equals 1/2, and we have 10 times 8, which is 40 units squared. A3 is just a rectangle, so it's 8 times 12. Okay, and that is A3 is just 8 times 12, which gives us 96 units squared. And then A4 is just a square. With sides 8. Okay, so A4 is 8 times 8, which is 64 units squared. Okay, now let's put all that in here. Okay, so we have the surface area then equals 2 times A1, which is 24, plus 2 times A2, which is 40, plus 4 times A3, which is 96, plus 64, because there's only one of those. So we have a surface area then of 48 plus 80 plus, and we have 2438, so 384. Okay, plus 64. Okay, so column addition is always easy. So if you line them up like this, then you don't even have to use a calculator, and it's good for your brain. So you add them up like that. 8 plus 4 is 12, plus 4 is 16, carry a 1. Then we have 4 plus 8 is 12 plus 13, then 21, 27, so 576 units squared, because we're dealing with surface area. So there's our surface area. There's our total volume. We did it for a complex shape. All right, that's it for pyramids. I hope you have a wonderful day. Bye-bye.